Up here. I apologize for the extended. You didn't have it up. We'll talk about it though. Here we go. Here we go. So, today's agenda notice, we'll finish the warm-up. And then we're going to talk about a new lesson. We'll have the floor. Castillo, have the floor. Thank you, gentlemen. Appreciate it. We're going to talk about a new lesson that's related to what you just did for warm-up. I had some technical difficulties. Sorry for the delay here. But I want to talk about what took place from the first parabola you punched in to the second one that you punched in. You guys, I saw your screen. You guys beautifully graphed those. And your graph, shoot, I think I messed up here. Give me a second here. It's a lot of line here. More technical. So I was looking at your computer screens. Your parabolas look beautiful, picture perfect, and I want to talk about some here. Check this out. So I got mine up on the board. So the one in red is the first one. F of x equals x squared. Do you guys remember Ekasan and Magani? I got the floor real quick. Do you guys remember what f of x means now from now on?
Yeah.
Or y. Huh? So y equals x squared. We're no strangers to that. The only thing that's new is the f of x. So look at the first one is. Let me talk. Thank you. The red one is the first one you graphed. F of x equals x squared. The blue one is. Look what ended up happening. I took the x and I subtracted 5 from it. And then I added a 3 way out here. And I put parentheses around the x and the 5. Kind of strange. And notice what happened here from the first to the second. The vertex that used to be right here at 0, 0, look at there, 0, 0. The vertex moved 1, 2, 3, 4, 5 units to the right. Look at where you see 5. Check it out. There's 5 right there. And not only did the vertex move 5 units to the right, it moved up 3 units. And where do you see 3? You see it right there.
Yeah.
So what we're going to get into now is taking a quadratic function, which is a parabola, and moving it anywhere we want, and manipulating its size and shape and its orientation. If we want to flip it down, we want to move it, we want to move it up, left, right, side, it doesn't matter. We're going to get into what we call transformations. Taking an original parabola and transforming it. That's where I'm headed today. So, what's the difference between these two? Well, it's 5 units to the right, move, and then up 3 units. That's the difference between them, the blue and the red. Yeah. The 5 is realized here, the 3 is realized here. We're rocking and rolling. I'm going to play this day in history. What you're going to do is wait upon me to give you the note guide. I'm going to come around and pass the note guide, so you don't need your own paper today. I'll come around and pass the note guide. I'm going to do things. I have a bunch of holes. You know, I appreciate it. So you got that note guide in front of you. Mine's going to be in color. Okay, on top, you have this summarized on your note guide, what I have here in color. So let's see what it says here. You have a bunch of space for notes. Okay? Let's see what it says here. You know, this is the wrong one. My bad. Hold up. Hold on. All right, here we go. Here's my new and improved version. Here we go. So, graphing f of x. Okay, you guys, I got to teach here. You got to let me talk. Stop interrupting me, please. I got a class to run, so you're already cutting me off again. Let me talk. Let's take turns. I got the floor now. Here we go. Let's do it. So, graphing f of x equals a times x minus h squared plus k. What in God's green earth is this? Well, you guys are used to this. Here we go. On this note section underneath, on the note section, go to put standard form. Go to write standard form. For the last month, you guys are no stranger to this form here. Watch this. F of x equals ax squared plus bx plus c. We know that. We can do that in our sleep. We're so used to that. But now I'm introducing you to a new form of a quadratic. Same stuff. It'll still become parabolas. This is a new form. It's called vertex form. We're going to write vertex form. We're going to be hanging out with vertex form for a while. Underneath, all the notes section. I got you. Come here. So standard form, vertex form. So look at vertex form. It's the same kind of function, but it's still quadratic, and it's still going to create a parabola like you just did right now for warm-up. But look how it's going to look. F of x equals a times x minus h squared plus k. It's a different form. By the way, this looks like a 9, but it's actually an 8. My bad. Now, why in the world would they call this funky-looking equation vertex form of a parabola? Here's why. Look what it says on top here. Yes, this is on your note guide. This top part's on your paper. So look at what it says here.
Oh, Mr. Wait, would you say that was an A or a 9?
That's A. We still got an A like the standard form, but now we got this binomial, a two-term expression in the second power. It's a little strange looking. Well, let's get into this. Well, here's what. H and K, look at this. The vertex is HK. Put a little star on this part of your notes that I just handed out. Put a box HK and put a little star there. That's why it's called vertex form. Because once it's in that form, you don't need a formula to find the vertex anymore. You can actually see the vertex here and here. The vertex, the x coordinate of the vertex is going to be h. The y coordinate of the vertex will be k. Let me prove it to you from the warm-up. Check this out. I still have my graph up here. Check out the warm-up graph. Notice the vertex. Let me plot it out here. The vertex is, excuse me. Thank you. The vertex is 5, 3. Look at the equation. 5, 3. You can actually see the vertex in the equation itself, hence the name. There's no mystery to it. It's called vertex form. Moving right along. So we got vertex form. Now, let's define the word translation. So I'm going to write the word translation. Underline it. This word translation is actually mentioned in this little paragraph up here. Look at the word translations right here. Okay? What the heck are they talking about translation? Let me define it. Translation is just a slide horizontally or vertically of a graph. A slide horizontally or vertically of a graph. When I was your age, I'd always get confused on the difference between horizontal and vertical. The way I memorize horizontal and vertical, so I memorize it, I don't have to ask anybody ever again. The word horizontal has the word horizon in it. So the sun comes out of the horizon from left to right. So go to put, if you forget what horizontal means, just put a left to right arrow. Vertically means up and down. Put a little up and down arrow so you don't forget. The way I memorize it is just horizon, left to right. So a translation is sliding a graph horizontally or vertically, which is exactly what we did for warm-up. I'll keep it up here. A slide horizontally or vertically of a graph. All right, watch this. We go back to the warm-up graph. I took the red graph and I translated it 5 units to the right horizontally and then 3 units vertically up. So the vertex, which was once at 0, 0, now became 5, 3. And every point on this parabola, look at all these points. Look at these ordered pairs. All these ordered pairs. Every single one of them moved 5 units horizontally and 3 units vertically. Every single one of them. That's what a translation is. I took the whole dang thing, 5 to the right, 3 up. We're rocking and rolling. Any questions so far? We're actually almost done with our notes. Today's a very short note session. Okay, so now. All right. We're going to write parent function, child function on the left and the right. Parent function, child function. We're going to kind of imagine that functions have children. That's strange, huh? Thanks, Williams, for ridiculing my lesson. That's wonderful. So a function having children. What the heck do I mean? Watch this. From now on, whenever I refer to the parent function, you're going to refer to this. You're going to think of this. Put f of x equals x squared. That's the parent function. And what does this function look like? Put a little x and y axis, a little dinky one, nothing crazy, no Picasso drawing. Go to write x, f of x here. Notice instead of the y axis, I write f of x axis. What will this function always look like? Well, it's always going to have a vertex of 0, 0, and it's always going to be going up. Okay, right at 0, 0. That's the parent function. Now imagine this parent function having a child. The child will look like the parent, but be a little bit different. Just like real life. You have a child, it's going to kind of look like you, but it's going to be different. If this function had a child, the child will look like this. I'm going to put it in Dodger blue. They're going to win the World Series next year, right, Mudio? I knew you'd agree.
Mister, are you recording right now?
Yeah.
Oh, dang it.
I did it way too much. Ready? Watch this. X minus h squared plus k. Here's the child. It looks like the parent, but here's the difference. All right, f of x equals x minus h squared plus k. The child is going to be different in this way. Underneath the h, go ahead and put horizontal shift. I'm going to put horizontal translation. Translation. Let's go translation. More appropriate. And what do you think K is going to be, class? Vertical translation. So the child will look different, just like warm-up. It'll look different, but very similar to the parent, but it's just going to be moved around. So this will be the vertical translation. Okay? Parent always goes through 0, 0 on the vertex. That's the parent. This parent's going to have a lot of children. And the children are always going to take this form. It'll be moved left or right wherever H is at, and up or down wherever K is at. That's it. That's basically the lesson today. Tomorrow, I'm going to get into some more examples before the quiz, which will be quiz 5. Oh, heck yeah. I can't think of a better way to celebrate Thanksgiving than with a big fat quiz.
We never take pills.